Hello everyone, this is Jay Coder back with another stream, and today I'm going to be going over some things in machine learning in Android. So I'm going to go ahead and show you guys a couple videos on that, and also we may go over some code in the future, but for this particular stream I wanted to go ahead and introduce you guys to machine learning concepts in Android so that we can have a foundation there. I have some other things planned for you all too in some future videos, such as different calculators that we can build and from scratch, and be able to help you guys to be able to build things with Jetpack Compose, like a full application and things like that. But anyway, without any further ado, I'm gonna go ahead and show you guys these videos, and thank you all for watching. If you like things regarding Android development and programming, things like that, I encourage you to go ahead and subscribe to the channel. Alright, I'm gonna go ahead and mute the music here, and we're gonna go ahead and start the video here. And so this first video I'm going over is called how to build a smarter Android apps with on-device machine learning. Well, actually, I want to start with this one. This one first. It's what's new in Android machine learning. This one will kind of expose you to some of the concepts first before we kind of dive into the more of the implementation. But all right, I'm gonna go ahead and play the video.
Hello everyone, my name is Dong Chen. I'm an engineer on Android. I'm going to share the latest on Android machine learning and show you how you can benefit from our newest offerings. Machine learning continues to enable new user experience across vision, speech, and language tasks. We see increasingly powerful mobile devices. We see tremendous growth in processing happening on-device. On-device machine learning has some unique benefits over server-based ML, such as improved latency, minimized exposure to users' private data, reduced power consumption, and the ability to provide a consistent experience even with no network connectivity. In addition, it can also save server costs. Many of the latest features on Pixel 6 are enabled with on-device machine learning. For example, Magic Eraser in Google Photos lets you easily remove distractions, such as an accidental photo bomb. Powered by on-device instant segmentation ML technology, Magic Eraser can detect distractions in the photo and then again use machine learning to predict what it would look like if the distraction weren't there. Another great example is the Pixel 6 Direct My Call. When you call a business, it can help transcribe the call in real time and present you with the call menu options, saving you the hassle of remembering which option to press. These features all run on-device. If you want to benefit from on-device machine learning in your own Android apps, there are two great options. First is MLKit. MLKit is a great starting point because it provides ready-made solutions through simple APIs for ML-powered features like real-time post detection, offline translation, and digital ink handwriting recognition, all optimized to run on mobile devices. The best part is, you don't need any machine learning expertise to use MLKit. If you do have some ML expertise, and either your use case is not covered by MLKit, or you need more control over the experience, you can go custom. In order to help with this, Android provides a custom ML stack, which consists of a set of supporting components that make it easier to deploy custom ML. This year, we have exciting updates on both MLKit and the supporting components provided by Android. Let's start with MLKit. Since launch in 2018, MLKit has been growing rapidly. Combining Android and iOS, its usage has more than doubled since last year to over 1 billion monthly active users and 80,000 monthly active apps. Over the past year, we have been making major updates across our existing APIs, improving accuracy, latency, and SDK size. First of all, we pushed the limit of performance through hardware acceleration. By enabling GPU acceleration for post-detection, we reduced pipeline latency by up to 43% based on internal benchmarking. On Pixel 6, we also enable TPU acceleration for object detection and tracking, as well as post-detection, and reduced their pipeline latencies by as much as 28% and 50% respectively. Additionally, we enable DSP acceleration for object detection and tracking on qualified devices. It sped up model inference by 3 times while consuming only 1/7 of energy based on our internal benchmarking. We also made some big updates to text recognition with a beta version of Text Recognition v2. In addition to the Latin script, we added support for Chinese, Devanagari, Japanese, and Korean scripts, dramatically expanding our language coverage. We introduced a deep paragraphing technology to provide better structural grouping. We also added the support for text written in all orientations. And even with all these improvements, we managed to boost recognition accuracy and improve latency by as much as 30% on Android devices. Thanks to the new script support, Text Recognition v2 Beta can now cover 37 languages, representing over 4.9 billion people worldwide. On top of these improvements, we looked for ways to make it easier to integrate MLKit into your app. The new Google Code Scanner API, powered by Google Play Services, utilizes the latest MLKit scanning technology. Using this API, apps can request that Google scans the barcode, QR code, and other codes on their behalf, and returns result without needing to request a camera permission or process the image within the app. This makes it quicker and easier to integrate code scanning features into your app, while reducing users' concern about having to grant camera permissions that can limit feature usage. Finally, I want to let you know that MLKit has an ongoing early access program. This can be a great opportunity to find out about upcoming MLKit APIs, or even influence their design by partnering with our engineering team. You can apply by following the link on the screen. Now, you may have a use case that is not yet supported by MLKit, or maybe you need more advanced control in deploying your own custom ML models. Last year, we announced a set of supporting components to make this easier. I want to hand it over to Ali to talk about the latest updates on those.
Thank you, Dong. Hi, I'm Ali, a product manager in Android. I'm going to talk about Android's custom ML stack, which consists of a set of supporting components that make deploying custom ML easier. As a recap, last year, we highlighted 3 areas where Android's custom ML stack would deliver significant improvements. First, making essential components for running on-device inference built in, so that you don't need to bundle them into your app separately, starting with TensorFlow Lite. And second, helping you get optimal performance across the ecosystem by using hardware acceleration wherever available. And third, providing regular updates to hardware drivers outside of Android Dessert releases with consistent support across OS versions. I'm proud to say that we made great progress in all of these areas. Let's start with the essentials. Last year, we announced the Play Services API for TensorFlow Lite. This API is now publicly available in beta. By switching over to this API for inference, you can immediately shave off up to 2 megabytes from your app size. Moreover, your app is likely to benefit from regular performance improvements. This is because the TF Lite team keeps optimizing performance in their latest releases, and these improvements will be picked up and delivered by Google Play Services automatically. In fact, during our early access program last year, some teams have observed as much as 20% performance improvement in CPU by migrating to the new Play Services API. TensorFlow Lite in Google Play Services is already being used by Google teams, including MLKit, and serving over 400 million monthly active users, running over 20 billion daily inferences. If you're interested in adopting, the API is almost the same as regular TensorFlow Lite. In most scenarios, we expect migration to involve making minor code changes, such as adding an initialization call and waiting for it to be completed. You can see that we use the suspending function here. This is a cool Kotlin feature that allows writing sequential code without blocking the UI thread. And once initialized, you can run inference as usual. And that's it. You can get started with this API today by following the link below. And now comes my favorite part, performance and hardware acceleration. Mobile devices nowadays are armed with powerful chips that can provide up to 10x latency improvement for ML inference. However, it has been hard to benefit from these capabilities due to variations in runtime latency, stability, and even accuracy across different devices and driver versions. I'm excited to announce Acceleration Service, a new API that will dramatically improve the experience for you. This API uses a technology called local benchmarking that helps determine optimal hardware on which to run ML inference safely at runtime. This technology is already used for pose detection MLKit, where it helped make it up to 43% faster. Acceleration Service is currently in early access preview, and you can apply by following the link below. And here's how local benchmarking works. At runtime, you call into Acceleration Service with your ML model and a few golden samples. The service then spins up new processes for testing each different hardware available. Running them at separate processes ensures your app doesn't suffer from driver stability issues, such as crashes or hangs. And after benchmarking is completed, you get a report on latency, stability, and accuracy of different accelerators. You can then choose the accelerator you want based on your business needs. And here's another cool part. The more devices you use this technology on, the better it gets as it collects telemetry and automates some of this decision making on the cloud. And by the way, you have control over when to run these local benchmarks. For example, you can choose to complete all of it in the app initialization time and get it cached. This way, your app will be ready to benefit from performance at future execution time. Now, earlier we talked about how we made TensorFlow Lite updatable with Google Play services in order to enable you to get access to the latest optimized inference engine. But getting the best performance also requires access to the latest optimized hardware drivers. This is why last year we announced Updatable Neural Networks API, which is now live in production under private beta. And this year, we're starting to make additional TensorFlow Lite delegates updatable as well, with Play services. This means you will get access to the latest drivers and delegates without having to bundle them into your app. You can benefit from updatable drivers using the Acceleration Service or target them directly. To find out more, please follow the link on the slide. Let's put it all together for Android's custom ML stack. TensorFlow Lite in Google Play services is now publicly available in beta for use. It will help you save on binary size and benefit from regular performance improvements. Acceleration Service is accepting applications to the early access preview. It will allow you to benefit from hardware acceleration without having to worry about latency, stability, and accuracy variations in user devices. Updatable hardware drivers are starting to roll out with Neural Networks API in private beta. Soon we will be making additional TensorFlow Lite delegates updatable as well, so that you can benefit from the latest optimized drivers and delegates seamlessly. You can access all of these APIs by following the link on the slide. Finally, we want to acknowledge that ML can be challenging. This is why the Android ML team is planning to do one-to-one office hours with Android developers who are actively working on an on-device machine learning related project for their apps. This can be a great opportunity to get direct help from Googlers about APIs, hardware acceleration, model convergence, and anything on-device machine learning related. You can apply by following the link below. I want to thank you on behalf of Dong, myself, and the Android ML team. We have links on the screen which will lead you to everything we announced today and our latest early access programs. You can also find them in the video description. Thank you for watching.
All right, so that is going to be our first video over the machine learning, and now let's go into the next video, how to build smarter Android apps with on-device machine learning.
Hello, my name is Thomas, and I'm an Android developer relation engineer working on machine learning. Today, I'm going to talk about the latest developments of machine learning on Android. I will show you how you can benefit from our latest offering, and we will see new ways to apply on-device machine learning as mobile devices become more powerful. On-device machine learning has advantages over processing data on the cloud. First, it enables low latency by eliminating a round trip to the server. It also lets you process the user's data while you keep them on the device. And you can provide your feature offline, since you don't need a connection to a server to run the inference. Finally, by running the inference locally, you will reduce your cloud bill. Let's take a look at a couple of experiences enabled by on-device ML. First, the new Lens AR Translate experience is a perfect example of the benefits of on-device machine learning. It uses a model to predict the pixels behind the removed text, allowing it to recreate the image. So the translated text appears seamlessly integrated as if it was part of the original picture. Here, the low latency enabled by running inference on the device is key. Second, the Android team in India is creating a solution to digitize important documents by scanning and extracting its key information. It leverages MLKit on-device text recognition API and other on-device ML classification models to classify the documents, example in this case a passport, and extract key fields. All of this processing is done on device. Today, you have two options to add machine learning on Android. First, MLKit. It's a great way to start. It offers a broad range of ML use cases packaged in simple APIs. Now, if you have ML experience and you created your own ML model customized for your use case, then you can use Android's custom ML stack. Built on top of TensorFlow Lite, it enables you to deploy ML-enabled features on Android and keep control over the inference process and the user experience. We have exciting updates to share for both MLKit and Android's custom ML stack. Let's start with MLKit and hand it over to David.
Hi, I'm David, Product Manager for MLKit. As Thomas said, MLKit enables turnkey ML features in your app without needing ML expertise. Let's take a look at what's new for MLKit. Over the last year, we have updated some of our existing APIs. By improving model performance, for example, we increased barcode performance by 17%. By delivering many of these APIs via Google Play services, so you don't have to bundle them and increase your APK size. For example, text recognition is now available in 5 scripts via Google Play services. And by adding new functionalities, for example, gesture classification in digital ink. We also constantly work on new APIs. We launched last year Face Mesh in beta, a very fast model optimized for selfie style capture for applications such as video conferences, AR, or selfie upload flows. And we are working on a new document scanning API. Let's take a closer look at some of these APIs. For barcode, we did not only improve the performance of our model by 17%, but we also added a new option for you to use a UI flow provided by Google, instead of you having to build your own. This is Google Code Scanner, and we just moved it from beta to GA. With Google Code Scanner, you get access to a high-quality flow powered by Google Barcode Model and a provided UI that is consistent across the ecosystem. This flow is delivered via Google Play services, which has low APK size impact and you can use with only a few lines of code. Finally, this flow helps increase user privacy. Once you trigger it, the user points at a barcode and the flow only returns the barcode scanned value. Given you're not processing the image or the camera, you don't need to ask for camera permission, which results in more privacy and safety for the user. We also brought a major improvement to our text recognition API and launched it via Google Play services. Now, you can extract text from images not only in Latin languages, but in 4 new scripts: Chinese, Devanagari, Japanese, and Korean. Together, these scripts cover over 100 languages. We also improved the model latency and accuracy and added some new features. You can now get the confidence score, the rotation information, and recognition at the symbol or character level versus previously only at the word level. This can be useful, for example, in Chinese, where a character can be a word. Last but not least, I wanted to talk about a new Android API we're building called Document Scanner. Digitizing physical documents is a very common user flow. Users turn to their phone to digitize, store, and retrieve important documents. For example, scanning your lunch receipt, your vaccination card, your children's homework. However, there was not a Google solution for this, and each app has had to build its own, which led to fragmented user experiences. That's why we've built a high-quality flow that can be used consistently across Android with a provided UI. This flow is delivered via Google Play services and is very easy to use. You can trigger the flow, and the user will be in control of scanning their documents in automatic or manual mode, cropping them, adding filters, and then sending them back to your app. And because it's done on device and the user decides which files to send back to the app, you don't need to ask for camera permission. We will be launching this flow later this year in Q4, but wanted to give you a preview today so that you can start thinking how to include it in your app. With that, I'll hand it over back to Thomas.
Thanks, David. Let's now talk about how to integrate your own custom machine learning model to your Android app. We heard your feedback, and we know that running custom ML inference on Android can sometimes be challenging. You have to deal with a vast ecosystem of devices, and identifying the best acceleration configuration for your model can be difficult. So today, I'm going to talk about Android's custom ML stack, a suite of components to make development of custom ML features easier and faster. First, we integrated TensorFlow Lite in Google Play Services as the official inference engine for Android. Second, we invested in hardware acceleration delegates to easily leverage GPUs. And finally, we created a new API to help you find the optimal hardware acceleration configuration for your model at runtime, the acceleration service. I'm very excited to share in details the progress we made. Let's start with TensorFlow Lite in Google Play Services. TensorFlow Lite in Google Play Services enables developers to use TensorFlow Lite for Android without having to bundle it with their application. As a benefit, the application binary size will be reduced by up to 5 megabytes. And as the new stable versions of TensorFlow Lite are fetched by Google Play Services, developers will benefit from performance improvements without any code changes. Finally, TensorFlow Lite in Google Play Services is the official machine learning inference engine on Android, which means that new APIs and services from Android's custom ML stack will be built on top of it. Since its launch in September last year, we've seen strong adoption. Today, it is serving more than 1 billion users monthly, and tens of thousands of apps are relying on it. Let's take a look at some of them. Internally, Google is actively leveraging TensorFlow Lite in Google Play Services to solve technical problems that didn't have a solution before. Have you ever ordered a rideshare that arrived on the wrong side of the street? The smartphone's GPS accuracy tends to drop in dense urban areas where the device doesn't have a direct line of sight with the satellites. Project Blue Sky, used in Android 8 and above, uses machine learning and 3D building representations to model effects of the reflection and increase the accuracy of the GPS in urban canyons, and, for example, solve the wrong side of the street problem. TensorFlow Lite in Google Play Services is also used by Android developers outside of Google, such as Wise. Wise is a UK-based company operating globally, enabling cross-border payments. Wise used TensorFlow Lite with Play Services to streamline the sign-up process. As new users take pictures of their identity documents to open an account, Wise custom ML model can evaluate the quality of the pictures and provide instant feedback to the users to properly frame it or to take a less blurry shot, for example. Verifying users' identity is one of the biggest costs for Wise's business. So ensuring users are verified easily and on the first attempt not only provide a great experience, but also decreases the costs for Wise. The MLKit team at Google also uses TensorFlow Lite in Google Play services internally. As a consequence, many Android developers using MLKit SDKs such as the barcode scanning API, language identification, or Smart Reply are also indirectly relying on TensorFlow Lite in Google Play services. Last but not least, it is also used by Stripe, a payment infrastructure company. They built an open source SDK for identity verification. Stripe runs two different image classification models to check the user's ID document and to validate the quality of a selfie, confirming the user's identity. By switching to TensorFlow Lite in Google Play services, Stripe reduced the size of the already very well optimized SDK by about 1.2 megabytes. If you want to integrate TensorFlow Lite in Google Play services, the API is almost the same as the bundled version of TensorFlow Lite. So the migration should only require minor code changes. To learn more about it, go to the TensorFlow documentation on tensorflow.org. Now, let's talk about hardware acceleration. In general, app developers don't really need to think about which chip is going to execute their code. Most of the processing happens on CPU, to the exception of graphics rendering handled by the GPU. It is different from machine learning features. Indeed, ML inference strongly benefits from leveraging the specialized chips such as GPU, the DSP, or the TPU for Pixel phones. We call it hardware acceleration. In testing a post-detection model on Pixel 6, we noticed that the inference was 180% faster on GPU than CPU, and up to 200% faster on Pixel 6 TPU, freeing up your CPU for other features. TensorFlow Lite delegates are integrated with TensorFlow Lite in Google Play services, and they are the best way to implement hardware acceleration in your app. Both the GPU delegate and the NNAPI delegates to support some DSP and the Pixel TPU are available via Google Play services. Like for TensorFlow Lite in Google Play services, you don't have to bundle them to your application and increase your binary size. And you will benefit from auto updates as new versions of the delegates are published without code changes. We are also actively working with hardware partners to bring more delegates to Google Play services. So to learn more about acceleration delegates and how to integrate them to your application, go to the documentation page on tensorflow.org. As we saw before, hardware acceleration can dramatically improve inference performance, up to 10 times faster in some cases. And as a consequence, it can significantly improve the user experience of your ML-enabled application. However, identifying the right hardware acceleration configuration for each device is challenging, given the variety of hardware on Android. The acceleration service is a new API built on top of TensorFlow Lite in Google Play services that enables you to pick the optimal hardware acceleration configuration for each device. Here is how it works. When the user opens your application for the first time, you will call the acceleration service API and pass your ML model, some sample data, and the expected inference results. The acceleration service will then run an internal ML inference benchmark with your model and data sample on the chips available on device and return a performance report and a hardware configuration recommendation that you can directly apply to your TensorFlow Lite interpreter. Today, it supports the inference on CPU and GPU, and we will be adding support for more chips in the future. As mentioned earlier, the acceleration service is already available in beta. So if you want to benefit from hardware acceleration without having to worry about latency, stability variation, we strongly recommend to give it a try. To learn more about it and integrate it to your application, go to the documentation page on TensorFlow.org. We covered a lot today. To summarize, if you want to add ML features without having to worry about training your own model, start with MLKit. If you have a custom ML model or you want to control the inference process or the user experience, then take a look at Android's custom ML stack. We can't wait to see what you'll build. ML on Android is constantly evolving. So to continue learning about it and stay up to date, visit d.android.com/ml. Thank you.
All right, guys. I hope you enjoyed the videos today, and yeah. And so go ahead and subscribe to the channel if you like this kind of stuff, and like the video and comment on it. And yeah, I would be interested if you guys made an application implementing machine learning, and we could make over a video in the future about that. But all right, guys, I'm gonna get off here for now. Have a great day, and as always, stay coding.